Let's work through this integration question. So in order to approach this, we need to use the method of substitution, and I like to think of that as 3 points. We are focusing on converting our derivative, d theta, in terms of u, our expression in terms of u, and our limits in terms of u. So let's start with d. Let's let u equal the denominator of 1 plus cos theta. So du by d theta is minus sine theta. Now in the question, d theta is the subject, so let's rearrange. To make d theta the subject, if we bring it up, we divide by minus sine. So that's d taken care of. Let's deal with our expression next. So on the denominator, u is 1 plus cos theta. We can leave that as it is. On the numerator, we have sine 2 theta. We've also got d theta, which we know is du, over minus sine theta. So now before we do anything, we've got minus sine theta on the bottom, and we've got sine 2 theta on the top, so let's use double angles to expand and simplify. What this does is cancels out sine theta, there and there. So what we've got at the moment, let's take that negative sign out along with the 2. Now we know 1 plus cos theta is equal to u, so cos theta is u minus 1. So our upper limit theta was pi over 2, and our lower limit was 0. U is equal to 1 plus cos theta. Cos of pi over 2 is 0, so 1 plus 0 is 1. Our lower limit is 0. 1 plus cos of 0 is 2. Right, let's group everything together. So our upper limit is 1, 2, u minus 1 over u du. Now, we can't integrate this just yet. We need to split this up into fractions. A general rule is if you've got a plus or minus b over c, you can write that as a over c plus or minus b over c. So we're going to use that here to split up our integral. U over u is 1, 1 over u du. Right, 1 integrates to u, 1 over u integrates to ln u. Put that in square brackets and add your limits on the right. Let's plug everything in, expand and simplify. Ln 1 is 0, so we can ignore that. Minus 2 minus minus gives us plus ln 2. So that's minus 2 minus 1 plus ln 2. If we expand and simplify, this gives us 2 minus 2 ln 2. And that's what we had to show, so we've got there.